Buenos días. Es un gran placer estar aquí con ustedes hoy. Gracias por la invitación y agradezco mucho las atenciones que me dieron los directores del programa. Muchas gracias para todo. Y con su permiso ya voy a continuar mi plática en inglés. So it's a great pleasure to be here. I think one of the things I was really looking forward to is to speak about agriculture today. Given the overarching problems that you're addressing here in this summer school, dealing with complex issues that require multidisciplinary or interdisciplinary problem solving. And I think agriculture is a great example of a domain that needs that kind of thinking. As I'll tell you today, 21st century agriculture has presented us with a variety of challenges. They're novel challenges, they're new challenges. I'm going to highlight technologies that are going to help us address these challenges of the 21st century, and I want to focus on the knowledge and skills that are going to be needed to use these technologies. So let me give you a short overview of what I'm going to talk about. First, I'm going to talk about agrarian development in kind of broad historical perspective. I'm going to try to situate what I talk about today in contrast to the questions that were asked 1 century ago. Then I'm going to go on and talk about some of the contemporary challenges in the global economy that impinge on agriculture. And I'm going to focus mostly on population growth, urbanization, and climate change. Then I'm going to go on and talk about at some length about the role of technology in addressing those challenges. And then I'm going to speak specifically, give you some examples of key technologies that I think are very important. I'm going to focus a bit on biotechnology and precision agriculture in conjunction with a new digital age of information. And one of the things when I talk about this that I want you to keep in mind, and I'm going to come back to this a couple of times, is the great promise of scale-neutral technology to deal with a variety of issues and challenges that we face in agriculture, but not only the diverse issues, but the diverse ways that we can address those issues. So this is an important point I'll come back to. And then I'm going to talk about the role of education in interdisciplinary studies in the agricultural domain. And then I'm going to finish by talking a little bit about how we have to think as universities about educating the workforce of the future that's going to be able to apply these technologies to deal with the world's problems. So that's all I'm going to talk about. So I'm going to try to get through this so I don't take time away from Professor Sonia. So, already skipped that. So I wanted to just start about and talk a little bit about the challenges of agriculture in the 19th century. And really the question a century ago that framed our thinking about agriculture was how was national economic development to take place? How did we transition from an agrarian to an industrial society? You can see that symbolized on these slides. And most important, what I want to focus on, what was the vision of agriculture in industrial society? So, if it moves. Christina, it seems to be hung up. There, that's the one. Yeah, good. Now we'll see if it keeps working. So, you know, one of the ways, and this came up a little bit in one of the readings that I sent you by Rostow, is kind of the thinking was kind of a simple contrast between traditional and modern industrial agriculture. Often we thought about contrasting the family farm on the left in the old days with industrial agriculture that was built around a proletarian workforce working with machinery and so forth. See, this first image, by the way, is the kind of farming that my father did when he was in Germany. They worked with horses and so forth. This is Leslie Daniels told us yesterday to think about our personal narratives. This is part of my personal narrative. And it's important for us in terms of thinking about what education is about today and how that contrasts from before. When you had this kind of agriculture, family farm, the idea was that family labor provided all the labor for the farm. Education wasn't that important. My father went to school for 6 years. He learned to read, write, do some arithmetic. He was a smart man, but they took him out of school because they needed him on the farm. And he always resented that all his life because he didn't get to go on further. But that was the way the thinking was in those days. But this is, I bring this up, first of all, to acknowledge Leslie and what she asked us to think about yesterday, but then also to contrast a little bit with the kind of old view of agriculture and what agricultural workforce needs in terms of education versus what the education needs are today, which I'm going to come to a little later. But most of the discussions, and this is probably the most important point here, were posed in this simple way. Could traditional agriculture versus industrial agriculture? And that there was either one way or another way, okay? And this was kind of this uniform view of the world. And so this was kind of the way the agrarian question was posed in the 19th century and the early 20th century. Traditional versus industrial agriculture. And how agriculture could contribute to the eradication of poverty, to industrial development and national development, and how an industrial proletariat would grow out of the agriculture. And presumably this would become a progressive force in society. So that was that discussion. But despite all the discussions about this, this is not how agriculture developed. Agriculture remained very diverse. And there were a lot of factors that inhibited the development of an agriculture, a factory-like agricultural development model. There's a seasonality of production. Makes it hard to recruit a workforce that works year-round as a hired workforce. We know that. There was natural variation in the conditions in which people produce and so forth. There are cultural traditions that vary widely around the world. These are just to name a few why agriculture remained very, very diverse. So agriculture not only remained diverse, it became increasingly diverse. And it's going to remain that way, is what I'm going to argue. You have large-scale mechanized agriculture. You have dispersed settlement in the American style. You have village-centered agricultural development in many parts of the world. There's a diversity of agriculture and there's a diversity of economic exchange. And this is where the agrarian question in the 19th century, I think, was fundamentally wrong. Because it looked at kind of a simple transition from one to the other. And in fact, there's diversity. And I want to argue that that was a misguided discussion and that there's no necessary or natural trajectory in agricultural development. So this is an important theme, and I want to take that theme and develop it for how we think about the present. So now I want to talk about agriculture in today's global economy. And today, even though we continue to talk about agriculture in terms of alleviating poverty, improving the lives of people, much more we talk about agriculture in terms of the global economy and how agriculture is integrated into it and how it's affected by it. Now, let me say a word about this. It came up yesterday. One of the questions, I can't remember who it came from, is about the global capitalist economy and how that impinges on people's lives. So I want to think about the global economy right now as a fact that has to be reckoned with. Not something that's necessarily good or bad, but it's a fact. Whether it's good or bad may depend on those multiple realities that Alan Goodman talked about yesterday. This global economy may be different for very different people and play out in different ways, but it's a fact that all of us have to deal with. So agriculture, food, nutrition are also foundational for the global sustainability goals that Melanie Greenberg talked about yesterday. If you think about hunger, health, well-being, natural resources like water, soil, energy, they're all directly related to agriculture. But how does agriculture affect the global economy, and how does the global economy affect agriculture? So the 21st century is less about nation building than the global economy and how people, regardless of their country of residence, relate to it. Global capitalism has created possibilities for incredible expansion of material wealth, allowing growth and concentration of human population to historic highs. But, as one of you pointed out yesterday, it's also led to all kinds of negative consequences as well, especially in natural resource depletion, various environmental problems that we have, and so forth. So as wealth expands, agriculture remains important in overall production, but it makes up a smaller part of the total economic output of a country, as we can see on this slide. But agriculture is important in communities throughout the world and makes up a varying proportions of the national economy in different places. So it's important in everywhere, but in very different ways. So one of the important things that I want to say is that in negotiating the diverse relationship between agriculture and the global economy in meeting human needs, the world is going to face many challenges. And there's three, as I mentioned before, that stand out: population growth, urbanization, and climate change. So, as you can see here, the agrarian question of the 21st century centers on feeding the burgeoning population. It's commonly noted that the world population is expected to reach 9 to 10 billion by 2050, with much of that growth coming in areas where agriculture accounts for the highest proportion of economic activity. Currently, the world population is about 7.4 billion, by the way. So in meeting the needs for this expanding population, there are several expectations of agriculture that I want you to take account of. It needs to provide a safe, abundant, and affordable animal feed, human food, fuel, fiber for a growing population. It has to provide financial stability for producers and contribute to the general well-being of farmers, farm workers, and rural communities. It needs to protect natural resources and the environment. So all of this tells you how big a challenge there is for agriculture. It not only needs to expand, but it has to be less resource consumptive. So this is a very important point. And then at the same time, as you can see on the slide on the right, hopefully the lines show up well there. I don't know, can you see the red line there? Not very well. What that second slide should show, the colors aren't very good for you, is that food production, I think you can see that on the white line, is starting to drop off, the increase in food production. Yet population is projected to grow on in a linear fashion, right? And so we're going to have a problem of meeting the food needs of the future. Keep this in mind. So urbanization. So I'll make an assertion here. I think that this diversity is going to be enabled by technology. And this is where I want to come back to the point I made earlier, and I'll make it again later, is what's really important here as a kind of enabling technology are those that are scale neutral, that provide access to global markets for producers, and that also let them take advantage of new developments in digital technologies and biotechnology and so forth. But we have to think that there's going to be diversity. So not all the technologies are going to be equally available or desirable for different types of producers. In fact, they may produce, some technologies may favor industrial type producers, others may favor small farmers. And so there's all kinds of different things that we have to learn to apply and think about. And then we also have to think about the beliefs and values of people about the type of agriculture that they want. There are debates going on in Europe, the United States, about going back to slow food and kind of traditional forms of agriculture and organic production and so forth, which is fine. That's an important part of the whole breadbasket, but then we also have to feed a growing population. And also those particular types of tastes that may be more amenable for people with greater wealth and they can afford that might not be good for rural people that are poor, right? And so there's this kind of type of diversity that I think we have to be ready to embrace, and we have to think about that. So 21st century agriculture is going to be tied to the global economy through new digital technology and breakthroughs in biology and computation that are going to allow producers to increase the amount of food produced, serve diverse markets, but also adapt to climate change. The question is what is that technology and to whom is it made available? And how can they apply that? Those are the questions, and I think those are the questions for us as university researchers and educators. We need to develop a workforce that has the knowledge and problem-solving skills to use this available technology. Now, this comes at a critical time. There was lots of investment, especially public investment, in research and development and agricultural research that allowed the growth of productivity from about the 1940s to the 1970s. And as I showed you in that one slide, that growth and productivity has started to level off a bit. So this is an important kind of time for us. As we're entering the new era for agriculture, we have to produce more with less. We have greater demand for food and fuel, and we have scarcer resources to meet those demands. The next great era of transformation and opportunity is going to be a new green revolution. We're calling it Green Revolution 2.0. And it's going to be a revolution that renegotiates the boundaries between agriculture, technology, industry, and society. It's all going to be reconceptualized in new ways, and we're in the midst of that. We don't completely understand it yet, but we're in the midst of that. And it's going to be an era that builds on all the discoveries in these past eras, consolidates those, and then takes us to new levels. So let me say a little bit about that. For this kind of a vision to be realized, there has to be investment in productivity increasing and risk reducing research and technology. Whether people can afford food in the future is going to be dependent on the ability to increase agricultural productivity, to continue to keep land productive, to make our use of water more productive as it becomes scarcer. And this all the time as the demand for food is increasing. So there's all kinds of knowledge constraints that we have to think about. Now remember the theme of diversity. There's all kinds of different conditions in the world that have made it impossible to have like one model of agriculture everywhere, right? And so there's diversity in all of this. This is what you see up here. Crops perform differently at different locations. So we need research that's adapted to particular needs, local needs. Could be the cutting edge technology, but it has to be adapted to local needs. Climate effects, as I've mentioned already, are going to be different in different places. Soil quality differs greatly around the world. We have to understand that and integrate that. And then there's losses due to diseases and insect infestations, different types of weeds. These are all local conditions. So these are all the types of issues that university researchers and educators need to address. We need to increase the pool of people that are trained for information and technology-based farming. It's essential if we're going to feed the growing world population in coming decades. And there's specific types of training that we need in order for this advanced technology to be applied in an appropriate way for local conditions, okay? So there has to be training in data analytics and information technology. Training in the use of precision agriculture techniques such as remote sensing, mapping, spatially specific input and output models. Training in systems-based agricultural production. For example, integrated pest management that allows us to reduce the amount of pesticides that we use in agricultural production. I'll come back to some of that a little later. And of course the use of economic modeling to inform decision making of producers. Also, not only do we have to educate students, not only do we have to educate farmers, but we have to educate the public about these technologies so that they understand them well. People are skeptical about a lot of the technologies that we're developing these days. There's a general mistrust of government and also a growing mistrust of science as well. So that becomes a job for us as educators and communicators to help people have a balanced view of technologies, their pros and cons, and to understand those well. And so this is another challenge for us as agriculture, as educators in agriculture, if you wish. So we have to think about addressing certain types of global needs, and we have to figure out how we're going to adapt these technologies to local conditions. And so these are some of the challenges that we have to invest in right here. As you can see, all of this long list, which I won't read to you, but I think that this is very important. We have to try to reduce competition from predators, for example. How do we do that in a way that we use modern technology and reduce kind of the disruptive and harmful technologies that we have? For example, we've gone through a lot of chemical technologies in the past that we know are harmful to the environment and harmful to human health. How can we avoid the use of these types of technologies? And then finally, as we develop all these technologies to deal with these specific problems, we need to educate the producers about the use of these technologies. So one of the things that I want to say to you is that one of the technologies I'd like to focus on is the possibilities of biotechnology. I think that biotechnology can open new frontiers for us. We're in the midst of a real revolution right now in biotechnology that most of the scientists who are working in the area tell me is just really will change everything. But it opens up new frontiers that allow us to improve nutritional content of grains and other food crops, increase yields on lands so we can feed the growing needs of the populations. We can reduce harmful environmental conditions. We can address challenges posed by climate change, like drought, excess moisture, temperature, salt intrusion, which is becoming a bigger problem as sea levels rise. We can reduce the use of insecticides and herbicides so that our farmers are safer, our food is more healthy. And then we can also improve produce quality and extend shelf life. This is important because a big part of the world's food production is just simply lost in waste and spoilage, right? And so we need to prevent that too as we go into the future. So I think biotechnology is going to be an important tool in addressing these needs. You know, there's already a number of technologies on the market. People are using these. You see insect-resistant crops, herbicide-resistant crops, very important in reducing chemicals. We have, I would say, golden rice is something that's an example of how we can biofortify foods to address nutritional deficiencies in people. So those are just a few examples. I would say also that we have probably about 60 to 70% of all the foods on the shelves in the United States are made up of genetically modified foods. So they're part of our life. And so we have to understand them a lot better and what they mean for us. So biotechnology is important. As educators, I think we need to try to understand biotechnology better. I mentioned the skepticism that's there in terms of people accepting the technology. But for the most part, most of us, and I won't speak for all of you, but many of us don't understand the technology ourselves. The general public doesn't understand the technology either. And they have real concerns about its safety. But one of the things we have to help them understand is what biotechnology actually is, what genetic engineering is, and what the different aspects of genetic engineering are, right? For example, people very often conflate transgenic types of technologies with genetic engineering in general, and that's not true, right? There's types of genetic transformations that are done without transgenic movement in the development of the plant. So this is an important point that I want to make. So one of the things that I think is important for us to do as we educate people is to begin to understand ourselves that there's revolutionary new genetic engineering technologies that are going to allow scientists to breed crops, as they've done for a long time. They've done for millennia. We've done for millennia. Not scientists, farmers have done it. We've done that for millennia, that allow farmers to respond to challenges posed by climate change, grow crops with enhanced nutritional benefits, and increase yields to feed a growing population. These are all possibilities of these technologies. So what I want to do now is give you a few illustrations of some of those technologies that people are developing at Cornell University. So we have, I think I have on the slide here, Professor Michael Gore. He's working on using genetic technologies, genomic technologies, to identify desirable plant characteristics and allow these crops to grow under increasingly erratic global climate conditions. So this is really a really important point. Professor Susan McCouch there is using genetic mapping to develop new rice strains that are more pest and drought resistant, that provide higher yields for farmers, that will create more stable global supplies of rice. And by the way, it's an essential food source. And one of the things that's really great about what she's doing, she's taking kind of the new generation green revolution type rice varieties and incorporating characteristics of wild varieties into those to enhance these crops so that they can meet the needs of the current conditions that farmers are growing in. Professor Greg Martin, he's researching the mechanisms that tomato plants have evolved to interfere with bacterial pathogens, again, reducing the need for insecticides and herbicides and all these types of remedies. And he's also studying wild relatives of tomatoes to develop, to identify new genes that contribute to plant immunity and that breed new tomato varieties that enhance this disease resistance. And then there's Professor Jim Giovanni. He's focusing on the molecular and genetic traits of fruit ripening that will have an impact on nutritional quality. So we're making the food more nutritional to meet people's needs. So these are all ways that you can use this new technology to address the real needs of people face now and into the foreseeable future. So we have some examples also that I think are worth noting. The development of the Gmo eggplant, the BT eggplant, that's being disseminated in Bangladesh and the Philippines. And it's improving health and nutrition. It's fostering a safer pesticide-free growing conditions. Now, if you think about this, The eggplant is in Asia is plagued by the fruit and shoot borer, and that results in losses, crop losses up to 60 or 70% of this crop that's a very, very important economic crop in that region of the world. 60 to 70% crop losses. It's incredible. The farmers, in order to avoid those types of crop losses, sometimes have to spray insecticides as many as 140 times in one season. So this BT eggplant has eliminated the need for that completely. So this protects the farmers, protects the environment, and allows this very healthy crop to get on the market at a reasonable price. We also have the Next Generation Cassava Project that is funded by the Bill and Melinda Gates Foundation, and that's working on improving disease resistance and shortening the breeding cycle of cassava in sub-Saharan Africa. Now this is really important because this is the staple food for more than 500 million people in Africa. Very important, yeah, very fundamental. And one of the things that they're doing, you'll appreciate this, they're bringing some of the genetic material from Latin America and integrating it into the crop stock in Africa to improve that crop. So I think that's a very important example. Now, the other thing is, so those are examples of the types of work that is being done that can be used. And I want to say again that this can be scale neutral. This is something that this BT eggplant is used by small farmers. This is not necessarily just produced for Monsanto, right? It's like something that can be used by small farmers. This is an important point, this type of technology. Well, we also have to develop and educate the students to use these technologies. So we have courses right now that I think are important. Michael Gore, that's on your left there, he has a course in high throughput phenotyping. And that's helping students to understand how to do this, how they use this to improve the productivity and quality of plants. So DNA phenotyping is a process of predicting the plant's phenotype solely from using genetic information. So that's very interesting. It's kind of cutting edge technology, and we want our students to know about this. The other thing that's important right now is that this new technology creates incredible amounts of data. This is one of the impacts of this, and we're trying to deal with how do we deal with all this data? How do we use this? You hear people talk about the big data problem. Well, this comes from this kind of genomic technology and so forth. So we also have courses like one that's working on coalescent theory and human population genomics that's helping students to understand how to conceptualize and then to analyze this new genomic data. We have another course on quantitative genomics and genetic that exposes students to analytic techniques used to understand the genetics of complex phenotypes when using this type of genomic data. And this is important in a general area that's kind of developing right now that we talk about as computational biology. That's kind of a new frontier. It's using kind of this big data to deal with this new type of data, to analyze it in a way that can be applied and then used to improve the process of improving these crops. It's kind of a fascinating development, cutting edge and very important. But we can also talk about precision agriculture and using kind of lower tech types of applications. For example, in India, we've observed the use of cell phones to disseminate information to farmers about market conditions, about getting information about the use of different types of agricultural inputs and so forth. You can bring the kind of the possibilities of the digital age right to the farmers across different types of scales. But the important thing is also being able to use geographic information systems to help farmers have kind of a real-time data collection and processing system that allows them to operate more effectively. So there's two parts of that, is kind of the actual technologies that allow you to gather this data and process it, and then the other is how do you communicate that to people so they can use it. Those are challenges for us as educators, how to get this technology out there and help farmers in different conditions make use of it. So one of the other things I wanted to mention just a little bit is some of the courses that we offer that allow students to learn about some of this precision agriculture technology. We have a course in applied remote sensing and GIS for resource inventory and analysis. We have another one on global navigation and satellite systems. And one of the things that I like about these courses, both of them, is that they give students kind of hands-on experience in using this technology. So one of the things I think the challenge we face as educators also with this type of technology, it's all right to talk about this in a theoretical way, in an abstract way, but then how do you actually use it? How do you apply it? How do you educate students about it? So one of the things that we're trying to do in these courses is give the students kind of direct experience so they can actually work with this technology in a very direct and active way and have more experience. And sometimes one of the things that we like to do, and this example on the lower left side on precision agriculture and nutrient management is an example of that, where we have students who have internships and they have projects where they go out and they actually make use of the technology and have a form of experiential learning. So one of the things we're working on that's very important as educators is not to just give students classroom education, but to give them some kind of experience, some hands-on experience. Very important in agriculture, I think. And we were talking about this the other day. It's absolutely essential. So I want to go on and just say a little bit about education and interdisciplinarity. And I think this is kind of a summary statement that I'll make, is that for agriculture to succeed in feeding the world, it needs a workforce that has the knowledge and problem-solving skills to apply the available technology. And universities play a central role not only in developing this technology, but also in educating the world and the workforce about how to apply it. So I want to give you just a few more examples of kind of some of the things that we're doing. In the area of, Toby Alt works in the area of extreme weather events, trying to predict those extreme weather events and help us understand how we can manage our production in that kind of a situation. And so there's this extreme weather involves a lot of very complex type of analysis, data synthesis, numerical and statistical modeling, and it also requires really an interdisciplinary approach. Now in his work on extreme weather, he brings together meteorology, obviously, with physics, with geography, paleoclimatology. They're trying to look at kind of the historical record as well, and then ecology, so you can understand the impacts of these extreme weather events in a local area. So that's a kind of an important thing. Another example is the TCI there. TCI means Tata Corneal Initiative. This is one that's, it's the Tata Corneal Agriculture and Nutrition Initiative. And so it's trying to reduce poverty and malnutrition in rural India. It's also working and doing that by protecting the environment and contributing to economic stability and human health. And one of the things that it's trying to do in terms of interdisciplinarity is also work across different institutions. So they're working with Indian universities, they're working with civil society. We talked about the importance of civil society yesterday with NGOs and so forth. And then they're working with local governments as well. So they're trying to enhance the local capacity to address food and nutrition problems in rural India. So it's also an interdisciplinary approach, and it brings together professors and students from a variety of disciplines, from nutrition, soil science, sociology, economics, and so they're trying to work and deal with these problems in a holistic way. And then the last one, CIFS, on the bottom right, is the Cornell Institute for Food Systems. And they're trying to increase collaborations amongst nutritional, plant, animal, food, economic, and management sciences. And it was kind of interesting because in the United States, when we talk about food systems, people have very different understandings of what that is. The food scientists have one idea of what the food system is. It's usually an industrial view of this. The nutritionists have a completely different view of that. And then the sociologists we won't even talk about. I'm a sociologist, so we won't even talk about that. So this is something, this institute is interesting because it's trying to bring everybody together so that they can talk about these problems in a coherent way, in a way where they understand each other. And remember, Melanie Greenberg talked about that yesterday in terms of the peace negotiation process as well. Remember? Because people sometimes use different languages to talk about things. When we talk about nutrition and food science, they have different languages that they talk about, sometimes the same things. So this is an interesting exercise of trying to bring people together so they can actually talk and understand. So, education, I want to come and just close on this. There's a lot of opportunities in agriculture. It's changing very quickly. Agriculture is not kind of the traditional activity that we thought about, only the traditional activity that we thought about a century ago. But it's something that's bringing modern science to meet the needs of diverse people and diverse conditions. And the challenge for us is how do we apply it appropriately in those conditions. And we need a workforce to do that. In the United States alone, there's a shortfall of over 20,000 educated university-level people to deal with the types of problems and jobs that are available for people. There's a lot of possibilities there. But we're not, even in the United States, we're not training enough people. Technological change, and this is what I'm trying to argue to you this morning, demands that we attract and graduate more students with skills relevant to agriculture and the environment, and ensure that during their time as students, they have opportunities for engaged learning, for building global awareness, cultural competency, and gaining a strong foundation in the liberal arts and sciences that give them context to apply their specific skills in agriculture and related fields. So that's kind of what you all are talking about in these 2 weeks, I think, is doing some of that. I think it's, I want to commend you on everything that you're doing. The people with the right skill sets have great opportunities, whether it's in biology, engineering, business administration, education, communication. There's needs for plant scientists, food scientists, engineers, people working with biomaterials. These are all things, this is what agriculture in the 21st century is there's a lot of those possibilities. And that doesn't mean that those types of technology don't exclude the small farmers or the poor farmers. In fact, the idea, the challenge for all of us is how you bring these technologies to the service of those farmers. That's back to my point about a diverse agriculture. We need to be able to do that, to serve all the people. So, 21st century agriculture faces significant challenges and opportunities, I would say. They're driven by population change, urbanization, and global climate change. We're going to have, I assert to you, a diverse agriculture, and we're going to need a diverse agriculture to meet these challenges because we need all agriculture to be productive everywhere in the world to feed the growing population. I think technology will enable that diversity if it's applied appropriately and developed appropriately. I've argued that universities play a special role to provide students with this diverse skill set so they can engage in interdisciplinary solutions to complex problems. I think that's what this summer school has been working on for the past 2 weeks. I congratulate all of you that you even have come to this and are taking on these complex challenges. And I think the organizers of this school deserve a great thank you for putting this together. So let's thank them.